My name is Kshetrajna Raghavan. It's a very hard name to pronounce, I get that. Most people just call me K, the first alphabet on my name. So if you want to talk to me after this presentation, you can come call me K. So let's get started. Okay, so show of hands. How many of you have heard of Shopify before? Okay, great. So I don't need to spend too much time on this slide. A few years ago, that would have been very little hands. We've grown now. Shopify is essentially a commerce platform. We provide tools for entrepreneurs to run their business. And you see all of those numbers up. I'm not going to spend too much time walking you through those numbers. It's publicly available. So suffice to say, we operate pretty much globally. We have merchants from across the world. If you've made a purchase online sometime in the past few years, I guarantee you probably made a purchase from a Shopify merchant. You probably didn't even know that you did, and that is by design, right? We consider ourselves almost like the operating system of commerce. So we're in the back end, we're in the shadows. We put the merchant front and center, and that's how we want it to be going forward as well. So a little bit about me. You've already heard my name. I work as a staff data scientist and a tech lead at Shopify. I work with a few different teams working on production machine learning solutions that actually give value to our merchants. So this isn't just ML in the backend. This is ML and putting it in production in front of our merchants to interact with on a day-to-day basis, right? I've had over 10 years of experience in various domains. So I try to be domain agnostic as much as possible because I do believe data science inherently is domain agnostic. It's solving problems, and that's kind of where I want to be, right? I don't want to solve problems only in one domain. I want to solve problems anywhere I can help. You see that word up there that says systems thinker. That's a loaded word these days, especially in a world where we kind of like move fast, hustle, do things. I truly believe, though, that those things aren't in conflict with each other. There is a way you can kind of go hacky, quick, build something quickly, but also build towards a more systemic and systematic future, and that's where the whole systems thinking comes in. And then obviously outside of work, I do have some interests in those specific orders, right? I have two large dogs. You'll actually get to meet them later in this presentation. And then, yeah, I play the guitar, I play the violin, and I spend most of my weekend video gaming as well, right? So with all of that said, here's my agenda for today. And I hope to get by all of these, time permitting. Otherwise, you can come to me outside and we can talk. So I'm going to start by setting up a problem statement, right? And it sounds like a usual thing. Like for me, a problem statement isn't a problem for me. It's a problem that I'm solving for a merchant, right? So I'm going to start, like when I say problem statement, this is a problem statement that every single Shopify merchant is going to face when they sign up to our platform and then they're trying to run their business. And then like the next 3 points are specific problem statements. I'm going to actually talk to you about 3 different machine learning models today, right? Not one. I'm going to talk to you about 3 different models and how they all connect to each other and how each one of them individually is solving a specific merchant problem in a very, very different domain, while at the same time also talking to each other and building on top of one another, right? And then finally, if I have the time, I will get back to the infrastructure. I heard a lot today about ML ops, infrastructure. I see Comet here. Comet is something that we use, so we'll talk about the infrastructure and how we've built a machine learning platform that enables our data scientists to move very quickly from prototyping something in a notebook all the way through to deploying it in production and running millions and millions of predictions every day, right? So with having said all of that, let's talk about the problem statement first, right? Let's put ourselves in the shoes of a Shopify merchant. You have a brilliant idea. You've decided that you want to start your entrepreneurship journey, and the first step you do is you sign up for a Shopify store, right? Great. You've now created this fancy looking storefront. What next, right? You even have a product. You have a great idea of what you want to sell, and you've created a Shopify store. Where do you go from there, right? Well, this is where we are right now, right? So we've created our storefront. The first thing you would want to do is you want to manage your catalog, right? You're probably selling multiple things. How do you manage your catalog? You're going to sync this with various channels. Maybe you want to sell just in Shopify. Maybe you're selling it across other channels, Facebook, Google, Etsy, wherever, right? So you want to sell across all these channels. You have to manage your catalog somehow. Let's say you manage to do that. Then you come across the holy grail of the problem that most entrepreneurs face, which is how do you actually get people to come to your store and buy something from your store? Let's say you magically are able to do that. Then you're now dealt with inventory management. How do you do inventory management? Like you may probably have multiple warehouses, you're fulfilling from multiple centers. How do you keep a track across all of these different things? Checkout. Not simple. Like I can keep going on and on about all of these problems. There's checkout, there's logistics and shipping, there is automations, right? And then there is finally fraud and fraud prevention, there's trust and safety, there's all of these things. Basically all this slide, the reason I put this slide up here is to tell you that running a business isn't easy. Like most of us here know it already. A lot of your entrepreneurs are already. Running a business isn't easy, right? And we at Shopify, we believe that we want to help our merchant in every single aspect of what you're seeing in front of you and more. And we believe machine learning is at the core of everything we do here. So that what we want to be able to do is allow our merchants to be able to focus on what they do best, which is the focus on great products, focus on selling it to people. Let us handle most of this thing for you, right? So I wish I could speak to you about every one of those clouds that you saw there. Unfortunately, I do not have the time, nor do I have all of that breadth of information of everything that Shopify does, right? But I'm going to talk to you about some few specific ones there, right? Specifically catalog management, right? We spoke about, hey, you're going to sell something, you're going to sell multiple things, and you want to manage your catalog. One of the first things you'd want to do when you're selling products is actually have structured metadata around your product, right? So in this case, and I promised you my dogs, those are my dogs, right? Let's say I'm selling my dog bed, not the dogs, just the bed, right? You see below there that there is, like I've given you a category below. It says animals and pet supplies. Within that, it's pet supplies, dog bed, right? That is a category, right? How do I know that? Well, for one, I could ask the merchant to manually give me that data, right? But that's friction, right? That's just more work, right? So we want to be able to use machine learning to automate that process. Then I'm going to talk to you, once I talk to you about that first problem, I'm then going to talk to you about a second problem that we're trying to solve for our merchants, which is called Shopify Audiences. This addresses the second bucket that you saw, which was the marketing bucket. And then finally, I'll come back all the way back to the first part and talk to you about something we do. It's the next step of product categorization, which is attribute extraction, right? So these are the three things that I'm going to talk to you about today. So let's go back and look at my dogs, right? So we want to sell this dog bed, and I can either go and ask all our merchants to input a bunch of metadata for every product they sell. Just for context, we have multiple millions of merchants, we have multiple billions of products, and we have tens of billions of images in our system, right? So for me to go and ask our merchants to manually input all of that data, yes, it's valuable for them, but it's also a lot of friction, and most of them do not want to do that. So we need to be able to automate this process as much as we can. And what do I mean by metadata? Well, we already looked at category, right? I want to know that this is a dog bed, but that's not the only metadata I can extract. I know what the color of this thing is, it's gray. I know what the shape is, it's rectangular. I know what the fill material is, it's memory foam, and so on and on and on, right? I can keep going on, but there's all sorts of metadata that we can extract from a product. So given that I don't want to ask a merchant to manually enter it, how do I now build a machine learning system that can do all of this automatically for me? And so the problem is twofold here, right? Like, actually, let's go back. It's very easy for me to say the category is dog bed. We can run a survey right now where if I remove the dog bed out of that and I come and ask 100 of you today what category this is, I'll probably get at least 10 different answers for what the category of this bed is, right? Because different people can call, if it's free form, then anybody can call anything, right? So the first problem in this is for me to get a controlled list of categories, right? I need a controlled list of these attributes. It just can't be a free-for-all. So the first step in this was to actually build a taxonomy, right? I need a controlled list of these categories. Well, I didn't want to do that. I'm lazy. I did not want to build a new taxonomy. I am not a taxonomist. So we looked around. There were actually Google has their own product taxonomy. It's called, obviously, the Google product taxonomy. And so that's what we piggybacked on, right? So the first step of that problem, we said, hey, I'm not going to even try to solve it. Let's go see if someone else has solved it for us. So this is one branch of the Google product taxonomy. The Google product taxonomy is a hierarchical structure. So you start off at the very top, right? So I can kind of say, okay, this product belongs to arts and entertainment, but it also belongs to hobbies and creative arts, on and on and on, and I can get to as detailed something as clarinet care kits, right? So it's hierarchical in nature. It's not just a flat set of labels, it's a hierarchical set of labels, right? So if I give you a dog bed, yes, it's a dog bed, but it's also animals and pet supplies. And a cat bed is also part of animals and pet supplies, right? So it just diverges somewhere along that branch, right? So the problem we truly have to solve is to not identify one single label that a product belongs to, it is to identify one branch that that product belongs to in the Google product taxonomy. So yes, we spoke about the problem, but what's the scale at which we need to solve this? Well, I already said some of these numbers. We have multiple billions of products, tens of billions of images, multiple million, and every day merchants are updating and creating new products, right? And so we need to have these categories and attributes instantaneously, right? Because some of these categories and attributes, they're actually critical to the workflow, right? Like maybe your product doesn't show up in search if you don't have the right category set up, right? Maybe your tax calculation fails if you don't have the right category set up. So we actually need these are actually in the critical path of commerce, so we need this to be done on a real-time basis in that scale. And then we have multiple consumers of this model, right? I already mentioned a couple, tax calculations, search, right? There's product sync, there is fraud, there is risk, there's all sorts of internal consumers. In fact, I do not think there is a single organization in Shopify which does not in some way, shape, or form consume this data. And so it's a diverse set of consumers. It's not a single consumer. It's a foundational piece of data for us, right? And then, like I said, there's multiple consumers will now mean multiple access patterns for them, right? So batch, so we support batch, we support real-time, we support streaming. Like we have to support pretty much many access patterns. So yeah, let's talk about, so that's the setup, right? That's the problem that we're trying to solve. We have the Google product taxonomy, and we have to now identify which branch a product belongs to. The first thing we did is, we didn't want to just stop at categorization alone, right? And you're going to see what I mean by that when we get to the attributes part of it. But what we wanted to do is build something that we were internally calling the product understanding engine, right? So I don't learn things in isolation, right? So when I learn that that chair in front of me is black, I'm not looking at it individually and just thinking, oh, it's black, but I'm also looking at it and saying, oh, it's probably made of wood, right? There's some commonality when I'm learning these things, right? So when we looked at it, we were like, I don't want to train a different model every time I want to learn a new attribute, right? I think there's some commonality to all of these things. Can we learn these things in some common format and then maybe specialize right when we need to, right? So the first thing we did was to treat this as a multitask problem, right? Each task is trying to solve a specific question about, or a specific attribute, or a specific question about that product. And obviously multi-class makes sense because there's multiple classes of the labels, right? So specifically for category, each level of the taxonomy, remember I said the Google product taxonomy is multiple levels deep. Each level of the taxonomy is treated as a separate task during training, right? What that means is for my dog bed, animals and pets, to predict that it's animals and pet supplies is a separate task, and then to predict that it's a dog bed is a separate task. We train those things together, but they're separate tasks in training, right? And each specific task, obviously, is a multi-class classification problem, right? Key thing to note is not all tasks are made equal, because remember, the hierarchy gets wider as you get lower in the taxonomy, right? So there is some complexity there where not all tasks are created equal. And then we didn't want to reinvent the wheel, right? The nature of the features for this particular task was we were using images, we were using free-form text, titles, descriptions, tags. And so we didn't want to reinvent the wheel. We said, hey, let's just go use some pre-trained model to create embeddings for these features. Specifically, we used multilingual BERT for text, and then we used MobileNet V2 for images. If you're asking me why we chose these, we worked on this probably a few years ago. This is probably ancient technology with what we're talking today. It still works, right? Like we don't believe we need to upgrade something just because the latest shiny object is around. It still works. The performance is still where we need it to be. B, even back then, there were other pre-trained models which probably gave us better performance, but because of the scale at which we needed to operate, we had to balance between cost and performance, right? So we essentially trained multiple models. We looked at, was it worth the additional, I don't know, X% performance to pay additional delta of thousands of dollars? The answer was probably no. So we ended up with these specific models. And finally, I've been talking about the model. How does it look like? Here's a very, very rough schematic of what the model itself looks like, right? Remember, the model is multiple levels. Each level of the taxonomy is a separate output or a separate task. So we start off by taking the raw image and the raw text. We pass them through the specific embedding layers, those pre-trained models I spoke to you about. And then I have a bunch of like hidden layers there, some multi-layer perceptrons sitting in there. And so the first thing we do is we predict that level 1 category, right? So animals and pet supplies, right? So we predict animals and pet supplies, or rather we predict the logit scores for all of those categories in level 1. What I then do is I take that prediction, I concatenate it back to the original features, and then I continue on to predict the next level of the taxonomy. And I do this on and on and on until I hit the bottommost level in the taxonomy. So one thing I did want to point out back here, right? You must be wondering, like, is this training taxonomy aware? What I mean by that is nothing right now in this architecture will stop the model from, let's say, predicting animals and pet supplies level 1, and then going down to level 3 and saying, oh, this is a screwdriver. That's perfectly allowed. Right now in this architecture, it doesn't know the parent-child relationship that exists in the taxonomy. Yes, the layers are connected, which means the probabilities will influence one another during backpropagation, but there's no hard constraint here that forces the model to only pick a child node once it's made a prediction of a parent node. Right? That constraint does not yet exist in the model. And I'm going to come back and say how we solved it. Right? And so what do we do during prediction? Well, this was the other thing. Remember I told you we needed to be able to support multiple access patterns, real-time batch streaming, right? And we needed to be cost effective. So what we did is instead of saving the model as one single combined entity, we actually broke it up into smaller chunks, each chunk doing one specific part of the entire model, right? So we have a text processing with the text embedding model saved separately, the image embedding model saved separately. We then have a model that takes the embedding and creates those probabilities for every node in the taxonomy. And then finally, you have some business logic that's appended in the end. And I'll come back to this business logic on why we need it. Now, what's the benefit of splitting this out? Well, let's say I'm doing this in real time. I can cache the intermediate results, right? So for example, let's say you as a merchant, you uploaded an image, you gave me some text and I made a prediction. You come back an hour later and now you changed only the image. The text remains the same. Guess what? I don't have to run the text embedding component of the graph again. I only create the new image embedding. I take back the old text embedding and I continue forward with the graph. So it gives me that benefit and it actually enables us to be a lot more efficient with how we do inference. So was this useful? In the end, like I spoke to you about a bunch of things. The last thing I want to do today is actually show you a bunch of ML metrics. We're all data scientists here, or we're all data enthusiasts. We can speak RMSE, MAE, blah, blah, blah. We can speak all of that. That's not useful. For me, what was useful is this actually helpful to our merchants? Is it solving a merchant problem that Shopify is trying to help with? And the answer is yes, it did, right? So this is actually an admin page. If you're a merchant and you're trying to sell this dog bed, this is actually what you'll see. And there in the bottom right, You see that blue thing that says dog beds? That happens in real time. Every time a merchant creates a product at Shopify, we're actually showing the prediction that the model made. It actually enables two things. One, it tells the merchant, hey, there is this field here. The merchant can do one of three things right now. They can either accept our prediction, which is great. They can either ignore our prediction, not so great. Or they can correct our prediction, which is even better, because what then happens is we use that as new training data for the model. And the way we measure, critically the product metrics we measure is the usage of this. How many merchants are actually using this, and how many downstream products does this power? Like this is, for example, very critical in tax calculations, right? We cannot legally make tax calculations based on predictions of a model, right? We need explicit consent from the merchant to be able to say, hey, this is a dog bed, so the tax rate for this has to be so and so, right? So we solved the metadata attribute extraction problem partially. And then we kind of like, okay, we solved a problem, the merchant's making use of it. Can we go beyond? Can we do something else with this data that we just created, right? And then we looked at it and we asked ourselves the question, what's the biggest problem that our merchants face today, and how can we use what we just created to solve that problem? Well, we already spoke briefly about it. One of the largest problems for our merchants is marketing, right? How do you drive traffic to your online store? Some of you are probably working in the ad tech space. There's been a lot of changes recently, which makes driving traffic to your website very, very hard. And I'm not going to name specific companies for it, but we all know what I'm talking about. And this is where the story of Shopify audiences began, right? So what is Shopify audiences? Well, Shopify audiences is essentially our attempt at creating a tool which enables our merchants to spend their marketing dollars in a more efficient way, right? What that means is typically what happens, right? You create your store. In this case, that's you. Forgive my stick drawing, that's you. You've created that dog bed. It's in your online store. And now you're trying to find your consumer, right? You have the whole wide internet, the scary internet available to you. You can go across these different ad platforms and you can bid on ads. You don't know how much to bid. You don't know who to bid for, right? And now you're like, okay, I need to find customers to get into your website, right? Like I said, you'd go to your ad platform and you'd do all of that. That's where Shopify Audiences comes in, right? So Shopify Audiences is our attempt at simplifying the world of online advertising to our merchants, right? What we essentially do is, okay, so remember, if you're a Shopify merchant, you're using all our tools, right? So you're using storefront, checkout, automations, you're using all of this. The reality is there's millions of other people also doing the same thing on the platform, right? So we actually have the power of the collective, right? We have that big network of Shopify merchants who are all purchasing things, who have consumers. And so what we thought was, hey, can we actually instead of us trying to help our merchants, can we let our merchants help each other? And that's where the story of Shopify Audiences came in. So what we did is before I tell you what we did, the other thing to note is that Shopify, the buyers on a Shopify merchant are probably among the most high intent buyers on the internet, right? Because think about it, right? Like these are people who are specifically going to a merchant's website, right? And saying, hey, I want to buy, in everywhere that I can find in the internet, I'm going to come to this one specific website and I'm going to pay you money and I'm going to buy your product, right? That's actually intent, right? And so it's actually very high intent customers. And so we were like, can we use our merchants to help each other through connecting them with other high intent buyers? And this is where the power of machine learning came in. This is where we used the category data we had built before. One thing I have to say, I keep saying we're using data across merchants. We don't do it without the permission of the merchant. This is explicit permission. Like if there are two merchants, they have to explicitly agree to share data with each other. So it's more of a sign-in rather than automatically do it for everyone, right? So how does it begin, right? So we start with a collective. The collective is all the merchants we have who've signed up to work with each other. And then we have the product that you as an individual merchant in that collective are trying to sell and trying to market. And then we have the product categories, which if you remember from 5 minutes ago, we've created using that machine learning model. And then we have our buyer pool, right? Our buyer pool is essentially all buyers in that collective, right? So maybe they are not buyers who've come to your store before, but these are buyers who have come to other merchants who exist in that collective. And so what we then do is I basically, without getting too much into the specific algorithm of how we do it, I basically look at it and say, hey, merchant A, you're trying to sell a dog bed. This buyer has actually purchased dog food from this other merchant, so there's probably highly likely that they're also interested in buying a dog bed. So that's kind of how we look at, and so what we do is we take the buyer pool, we look at past purchase data, we do affinity scoring to the product that you're trying to market for, and we filter it down to an audience set. That audience set is now exported back to your ad platform of choice, and then we can run targeted advertisement on the ad platform. So this is already proven to generate a lot more return on investment for ad spend. Yeah, that was the story of Shopify audiences. And I want to run through quickly because I want to get to that last problem as well. So we solved so now what have we done, right? We've solved the category problem. We've had direct uses of it. We've then taken that and created indirect uses to build new machine learning models on top of it. That now gives us more confidence that, hey, let's go back to that original category problem and try to see if we can do more than just category. And this is where attributes comes in. So obviously, remember, I spoke to you about the dog bed. I said it's not just that it's a dog bed, it's gray, it's rectangular, it's memory foam, it's all of those things, right? So the first thing we needed to do for the category, we got lucky, right? Google just gave us the Google product taxonomy for free. Unfortunately, that doesn't exist for every other attribute that I want to predict on, right? So now I can't be lazy anymore. I have to actually earn my pay and I have to solve this problem, right? I still don't want to solve it, right? This is not something that data scientists are good at, right? If you come to me and you ask me, hey, what are the attributes for a dog bed? I can probably answer that question because I like dogs. But if you ask me something else, I do not know. As a data scientist, I am not qualified to be able to answer that question. We then thought, oh, maybe we can go into the data and see what kind of free-form text our merchants are putting and do some NLP there to see if we can create a synthetic taxonomy using data that already exists in through our merchants. Yeah, that didn't work either, right? So we quickly realized we actually needed domain experts in each of these things, right? Like if I wanted a taxonomy of attributes for fashion, I needed to go talk to somebody who actually knew fashion, right? And that's kind of what we did. And the other thing we quickly realized is attributes are a subset of categories, or they're directly dependent on the category. The attributes that I spoke about for dog bed do not make sense if I'm talking about t-shirts, for example, right? Like fill material doesn't make any sense when I'm talking about t-shirt. It just doesn't, right? So each specific category has a specific set of attributes, and each set of those attributes has a specific controlled list of values. And all of those categories, attributes, values, that's where our domain experts came in. And these were the people who were coming and telling us, hey, for t-shirt, these are your attributes and these are the values for these attributes, right? So we had our domain experts do that for us. Not only did they do that for us, they then created a small sample data set using annotators for us. Like this is high quality training data for us. They would create a training data set for us. And then we basically had an automated training process that would take that in. So what this means is for us to create a new attribute for in a new category, data scientists don't need to do anything, right? Because the domain experts will create that data set. They will send it to our manual annotators who will annotate the data set. And then we'll pull it in through our automated training process and it will just create that new model. All of this is automated, right? And yeah, you see an example of that there, right? For a t-shirt, it says, hey, color, type, waist, neckline. Like we have all of those things. Right now, we only do it for the fashion domain. We need domain experts, and right now we're doing it for the fashion domain because that's one of our biggest areas, but we will expand into other domains. So where's the commonality in this? Like I spoke to you about 3 different models. Where's the commonality in it? Well, for one, working with images is not easy, especially at the scale that we were talking at. Working with images is not easy. So we basically share the ingestion pipeline. The image download pipeline that we built for product categorization is the same pipeline that we use for attributes. In fact, even the embeddings are shared across these models. We take the same embeddings and then we pass it across the attribute models. So we actually do a lot of cost and time savings just by sharing these components across these different models. Yeah, so I wanted to get to this slide because I know there's a lot of people who are interested in the actual, how did you do, what kind of infrastructure do you have, right? At a very, very, very high level, this is how our data platform infrastructure looks like, right? So let's actually start off all the way to the left, right? Because it's almost like a timeline of how we evolved, right? What we did have existing before was a pretty mature data platform, right? So our data scientists were very used to running Spark, running dbt, SQL, Flink, right? The typical data processing tools we were using very well, right? But we quickly realized that for machine learning, this isn't enough, right? Not to say that it wasn't needed, it wasn't enough. We needed something in addition to what we already had. So that's why we then created the second box that you see, which is our machine learning platform, right? Some of you might already recognize some of the words or the names in there if it's big enough for you to read. I now realize it's too small. But essentially, the machine learning platform is built on the same Kubernetes production platform that the rest of our production code runs, including our data platform. And so on top of the production platform sits this open source library called Ray. Some of you might have heard of it. Ray is essentially a library which allows you to distribute Python code across multiple workers, right? You can write, what this allows is it allows data scientists to write regular Python code and then that gets distributed across. Why is that useful? Well, when we're dealing with large amounts of data, it's very easy for our data scientists not to be, oh, I have to use Spark. No, you don't have to. You can use Python and you can just distribute it across using Ray. Ray also supports distributed TensorFlow, distributed Torch, XGBoost. It supports a bunch of machine learning libraries. And so Ray is kind of the foundation on which the ML platform was built. What that allows us to do is there is a concept called a workspace within our machine learning platform, right? So what that means is as a data scientist, I can go and say, hey, I want these set of libraries. Maybe I'll say I want Python 3.x.x, I want scikit-learn y point blah, blah, blah. I can then say I want these set of hardware requirements. I can say I need this many workers, this kind of CPU, this GPU. And then I can say I want this many workers and distribution. So not only do I choose the live software, I also choose the hardware. And the great news about this is that there is absolutely zero difference between the environment I use when I'm running in production versus the environment I use during dev and prototype, right? Because it's essentially I'm controlling the hardware and the software and I can control it exactly in the same way. Of course, what that means is costs during dev can be high. And so we have guardrails in place to kind of avoid that. But it does give you the ability to have exactly the same environment in both production and staging and dev. And then beyond that, we have some additional services. We have the model registry. We actually use Comet for our model registry. We use Feast for our feature store. And we have an online inference service that's custom built for us. Right? What this allows us to do is now I can take that one model, I can use Ray to distribute for batch processing, batch training, batch prediction. I can use online inference for real-time use cases. And then I can come all the way here and there is Flink, the streaming engine, and I can plug my model there for streaming inference. So this is the last slide I wanted to stop at, right? I'm standing up here and I'm telling you, oh, we did this, we did that, we did this, right? The reality of it is, it took that many teams, and each of those teams has some very, very, very capable people in it, right? It actually takes a village to build something as sophisticated and impactful as this. I'm standing here today on the shoulders of some very great colleagues, the best I could ask for, and that is the message I want to give today, right? One, focus on your consumer. It's very easy as data scientists to get sucked into, oh, I'm going to improve this one specific ML metric by X%. Do not do that. And B, do not think that you can do everything by yourself. You actually need a team of very talented people to complement your skill set. And that's exactly what we've built at Shopify. And so having said all of that, if we have time, I can take some questions now.
Thank you for your great presentation. So, but anyway, I believe a huge number of AI models and machine learning models in the Shopify systems. Then anyway, I want to know the general lifespan of the machine learning models because, yeah. So how long machine learning models can be used in average?
Yeah, I hate to start an answer with it depends, but this is one of those cases where it actually depends. For example, within those three models that I showed you, right? The first model can probably be used for longer, right? Because category information doesn't change very drastically. What used to be a t-shirt 6 months ago is probably still a t-shirt today, right? It doesn't change very often. We do stuff like monitoring regular performance, drift detection, we do all of that, but those kind of models typically don't need to be retrained very often. But the second model we spoke about, the marketing, the audiences model, that probably needs to change. Like you need to retrain very often, right? Because consumer behavior changes, it's very contextual, it's very time dependent. So yeah, it depends. It really, really depends on what the model is, what kind of architecture. But the commonality in all of this is, regardless of how comfortable you think your model is in production, it really needs that monitoring and the drift detection and all of that around, so that, yeah, don't rely on instinct, actually rely on the data. That's what the model is telling you.
Thank you. But anyway, how about the shortest one? So 1 week or 1 month?
Sorry?
How about shortest one? So how often changes it? 1 week or you need a few weeks?
Oh,
or
yeah.
You can,
if I understand the question correctly, you're asking what's the shortest life cycle of a model?
Yeah.
I've even seen models on Shopify that are trained every 15 minutes. Right? So again, not something I've worked with, but yeah, in those three, I think that's probably like daily training cadence. I think so.
Thank you so much.
Thanks for the talk. I have a question about what you spoke about at the end about getting in your consumers' shoes. Like, how does that look like for you and your data science team at Shopify? Because there's such a huge number of consumers.
Yeah, it's not an easy problem to solve, and I wish there was like this one magic bullet that I can tell you that this is how you solve it. The reality is, communication is key, especially in an organization the size of Shopify. Like, communication is very key. I can only speak for myself. I make it a point to have regular check-ins with my consumer to say, hey, what's going on? Like, what do you need from this? Like, even if everything looks like it's working, like, I'm still talking to them to go, hey, what do you have coming up 3 months from now, 6 months from now? Does our current solution satisfy your roadmap, right? Because it's very easy to get into this mode of, yeah, everything's working today, but then they come to you 6 months from now and say, hey, we're launching this new product and what you're offering us today, like right now, isn't enough for us, right? I would rather have a little bit more heads up than that. Yeah, but we have an army of product managers and people like me doing the communication with our consumers, but yeah.
So you speak directly to the consumer, not going through sales?
When I say consumer, most of my consumers are internal teams. There are other teams, right? So yeah.
Thank you.
Thank you for the amazing talk. I have a question regarding your multitask, multi-class architecture. So essentially, the hidden layer would then feed into level 1 and then another hidden layer and then level 2. I'm curious whether you're leveraging your Google product taxonomy, that knowledge graph kind of thing in terms of the different layers. In other words, do you ever see productions that are inconsistent with the Google product taxonomy, and how do you deal with that?
Yeah, I probably should have touched on that. So you're right, like during training, there are potential scenarios where, like I said, it'll predict animals and pet supplies in level 1 and then say screwdriver in level 2. The way we prevent that from going forward is, like, remember in that file, like in the inference graph, I said business rules. What we do is we actually enforce, like we've hard-coded this in, after prediction, there is a final business step that, so what the prediction does is it essentially gives you probabilities for every node in the taxonomy, right? So then what I do is I say, okay, give me the prediction of the max probability at level 1, right? It'll tell me animals and pet supplies. Then what I do is I say, okay, I know that it's animals and pet supplies in level 1. throw away everything that's not a child of animals and pet supplies at level 2 and give me the max of that, right? So what I do is I artificially then impose the taxonomy during prediction, and that actually gets hard-coded back into the model. So it's not like we have to run post-production code, it's actually baked back into the model before we deploy.
So what triggers retraining of any of your important models? Is it just anomaly detection, regular monitoring, or is it certain thresholds that are looked out for?
Yeah, again, it depends. Some models are just scheduled for regular cadence, right? So we'll say, hey, train this every week, every month, every 6 months, whatever. Other models are specific event triggered, right? So maybe the merchant does something. For example, audiences, the merchant will come in and say, hey, I want to create an audience set for this product, right? And that's when we'll trigger like an entire prediction, not a training, we trigger the prediction at that point. There are also, and then we have drift detection and monitoring, and sometimes when that threshold falls low, it'll automatically trigger another retrain. So it depends on that specific model and on that specific use case.
All right, thank you so much. That was a wonderful.